So welcome back to the third part in our Numpy lecture for this week. So in this one, we're going to look specifically at array math. We call array concatenation, which is merging two arrays or more arrays together, and look at some we call array reduction features. So things like getting some statistics, so column averages or column minimums or row minimums, things like that. So reducing it down to a simpler state. So the first thing that we're going to do is import the Numpy library. So import Numpy as NP, just like we did before. Again, this is from the last lecture, so the idea of missing data and assigning NaN values. So we've already covered that, so that's just here to kind of remind you of that for future operations as well. So if we want to do math on an array, most oftentimes this is doing what's called an element-wise operation. Okay, so if we take an array like this, okay, so 1, 2, 3, 4, 5, 6, 7, 8, so a 2 by 4 array. Okay, there it is in our variable explorer here. Okay, if I say I can tell Python to give me that array plus 1. Okay, and so what I mean by element-wise is that this math operation of plus 1 is going to go to every element of the array. Okay, so every cell of the array is going to kind of receive this math function of plus 1. Okay, so if I run that, so now you can see our plus 1 array here is, instead of being 1 through 8, is now 2 through 9. Okay, so we've added 1 to each of those different elements in the array. Okay, and this works for all the different math operators that we've looked at. Okay, so we can do the array squared, okay, and get something that looks like this. Okay, we can also use the array as a kind of, rather than being operated on, we can use it as an operator. Okay, so in this case, I want to take 10, the value of 10, to all the different powers of the array within the array. Okay, so we can actually use that array as the exponents in this math equation. Okay, so in this case, if we do that, now we get, okay, so it'd be 10 to the 1 is 10, 10 to the 2 is 100, 10 to the 3 is 1,000, on the way up to the top value there. Okay, and so in a more practical sense, what we can do is take, say, an array of temperatures. Okay, so let's pretend that this is an array of temperature values from a weather station. Okay, but they're in Fahrenheit. Okay, so temperature underscore F for temperature in Fahrenheit, and it's an array of values that we have here. Okay, so this is just a range of values from -44 up to 100 Fahrenheit. Okay. And so if we wanted to do a conversion to Celsius, okay, we could use the formula that is kind of the standard Fahrenheit to Celsius conversion. Okay, is the temperature minus 32 times 5/9. Okay, will get us temperature in Celsius. Okay, so if we run that, again, that's going to run that equation on every cell in our array. Okay, so in this case, we get values that are now in Celsius. Okay, so we have -44 in Fahrenheit becomes -42 in Celsius, 32 Fahrenheit becomes 0 in Celsius, 100 in Fahrenheit becomes 37.7 in Celsius. Okay. And so the nice thing is, again, we can use that, then the results of that, to then say if we wanted to convert to degrees Kelvin. Okay, so temperature in Celsius plus 273.15 will give us degrees in Kelvin. Okay, so now we have an array of Fahrenheit, an equivalent array in Celsius, and a third equivalent array in Kelvin. Okay, so when we're doing math operations on these arrays, okay, they're going to be doing them across all of the values. So Another way to do arrays, okay, is to do what we call array to array math. Okay, so if we have two arrays that have, the trick to this is that they have to have at least one dimension in common. Okay, so in this case, we're going to look at something that's right up my alley, which is looking at calculating river discharge. Okay, and so in this case, river discharge, generally we use the letter Q to denote that, okay, is a function of the cross-sectional area of the river. So if we survey a cross-section across a river, okay, we can get the cross-sectional area of the water. And then we multiply that times the velocity of the water moving through that cross-section will give us discharge. Okay. So if I have a series of velocities that I've measured here, so river underscore v would be an array of velocities, and then I have a matching set of river cross-sections, okay, in this case like this. So I've got a 2x4 array of velocities and a 2x4 array of cross-sectional areas. Okay, what I can do is, again, you could try to do this one cell at a time, but that's not going to be very efficient. And so the easiest way to do this is to do this, we call array to array math. So in this case, we can take our cross-sectional area array, multiply it by our velocity array. And what's happening in this case is that each cell is going to is going to kind of multiply by the matching cell in the other array. Okay, so it'll go through and do the 0, 0, and then 0, 1 on each array and do those in kind of that same element-wise fashion, but since we have two arrays, it's going to do each cell times every other cell. Okay, so if we run this equation, okay, you can see that our result here, okay, so we have our cross-sectional area is 2x4, our river velocity is 2x4, and then our output discharge in this case is still 2x4. Okay, so we have 10, 21, 33, all the way up. Okay, so each cell went to its matching cell in the other array to get this result out the other side. Okay. If you don't have arrays of similar size, okay, or exactly the same dimensions, so in this case we had 2x4 in each of ours, okay, you can do math between arrays that have at least, like I said, one dimension in common. And then what happens is that the smaller array is going to be what we call broadcast over the other array. So the way to visualize this is if we take this array A here, okay, and I'm actually going to clear out my variable explorer so we can get a clean view of this. Okay, so we have this array A. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. And then we have an array B here, okay, that is, in this case, a one-dimensional array with 4 elements, okay. And then we're going to throw in here this is a 2-dimensional array, but it only has 1 column, okay. So this is what we call a 2x1 array. So 2-dimensional, 2 rows, 1 column, okay, which is slightly different than a truly one-dimensional array. Okay, so the question is that we have a 2x4 and then a 4 array. So if we did A plus B, we don't have exact matching cells to match up. But what is going to happen is that basically we're going to take, since B has 4 values in it, and that matches the columns in our first array, okay, it's basically going to say, okay, well, I'm going to take B and add all those values to the first row. And then since the column number matches, I'm going to go down to the second row and do the same thing. Okay, so if we look at that, okay, you'll see that the column, what we call column-wise addition here, we ended up with a 2x4 again, which is the same as our input array there. But essentially what we've done is taken B and added it to A by the columns. Okay, and then similarly, if we have the C array here, which is a 2-row by 1 column array, and we add those together, Okay, that will take that. So in this case, it'll take the 100 in the first row of C and add that to the first all the elements in the first row of A, and then the 200 is the second row, and so that'll add to all the second row in A as well. So you can do some, you can start to get crazy with these, okay, so you can say, you know, the complex math knows no bounds, okay, once you start getting into this. Okay, so running something like this, and so we go A plus C times C raised to the power of 0.5, which is essentially the square root. Okay, we can get an array out of values that looks, that can be rather complicated. All right, so the next thing that we're going to look at, okay, is combining two arrays together. Okay, so math operations will do math between two arrays, but let's say we want to take one array and add on a new row or add on a series of rows or a series of columns. We do that through what we call concatenation. Okay, so we're going to take one array and then add on either rows or columns to that original array. Okay. So again, this is something you have to be aware of, is that we really need things to be similar sized in order to concatenate them. Okay. And so there's a couple ways to do this, but let's just look at what our inputs are here. Okay. So if I have these two arrays, A and B, okay. So a 2 by 2 and a 1 by 2. Okay, so one row, two columns versus a 2 by 2. Okay. There's a couple of different ways that we can kind of concatenate these two together. Okay. And so the thing that you need to understand here, okay, and this goes for a lot of array operations, is that arrays have what we call axes. Okay. So in this case, the concatenate function takes an input that says axis equals, and then you have to tell it which axis you want to concatenate to. And so in Numpy, generally what we call the 0 axis is the rows, and then the 1 axis is the columns. Okay, so if you think about this in terms of your indexing, okay, the 0 value, or the first value in an index is the row, and the second index is the column. Okay, so 0 and 1, 0 rows, 1 columns. Okay, so in this case, we can use a function called concatenate. Okay, and so this is np.concatenate. We have basically a list of the arrays that we want to concatenate together. So in this case, we're going to take A and add B onto it. Okay, on the second, or on the rows axis. Okay, so if I do that, so you can now see that we have a new array C here, okay, that has 5 and 6 from B added on as a new row here. We could take those two values from B and add them on as columns. Okay, and to do that, we'd need to transpose B, which is to flip it from being a row to being a column. And then we can add it on to axis 1. Okay, so this again is, we skipped over this a little bit in the last lecture, but B.T is to transpose that. So it basically takes it from a row to a column. Okay, so I can run that. And now you can see I've got 5 and 6 over here as a column. Okay. There are some other ways to concatenate as well, okay, with what we call V-stack and H-stack. So V-stack is vertical stacking, H-stack is horizontal stacking. So vertical stacking is rows, horizontal stacking is columns. So it just basically stacks up the different arrays. Or there is another one that is called row stack and another one called column stack. Okay. Essentially, all of these do the same thing. Okay, but some of them have slightly different. Some of them have some additional functions or variables that you can throw in there. So if you're interested in those or you need to start using those, you can start with concatenate. I tend to stick with VStack and HStack since that kind of matches kind of what I have in my mind from one of my previous programming languages. But these all do basically the same thing. And so the trick is just to play with them and figure out which one you need. All right. Last thing for today is to talk about what we call array reduction. Okay. And so most of these are kind of things that allow us to kind of we call reduce the array down to kind of its component parts or to some statistical a statistical component. Okay, and so this is things we can do is look at, say, like adding up all of the elements in an array. Okay, so if I have, I'm going to clear my variable explorer one last time. Okay, so in this case we have this array A, okay, which is a 3x4. Okay, and in this case, what we can get out of this, if we want to add up all of the values, okay, we can just say a.sum with just an open closed bracket here. We'll basically add up all of the values in that array and spit out one value. Okay, so that's the idea of reduction. So we're taking an entire array and reducing it down to a component part. Okay, so in this case, the sum of all of those, the addition, if we add all the cells up, okay, in this case we get a value of 31.1999999 repeating. Okay. Some of these functions you can throw in an axis variable as well. Okay, so in this case we can look at the sums in each column, okay, or the sums in each row. Okay, and so if we run those, okay, you can see that we get two different outputs. Okay, so in this case we had 3 rows. Okay, and if we sum up each row, okay, so the sum of the first row is 10, the sum of the second row is 10.4, and the sum of the third row is 10.8. And then the sum of the columns, okay, so if we look at this on a column basis, so these are a little bit flipped just because Spider doesn't like dealing with the one-dimensional array output, but 1 plus 1.1 plus 1.2 is 3.3, 2 plus 2.1 plus 2.2 is 6.3, and on down the line. Okay. You can get the minimum and maximum values in a row or a column, okay, by doing, or for the entire array. Okay, so if we run this, so a.max gives us the max value of the array, which is 4.2. Okay, the minimum value is 1. Okay, but you can do this on a row basis or on a column basis just the same. Okay, so other things, again, you can get the average value of a row or a column, or for an entire array, the median, the standard deviation. Okay, you can get there's a lot of statistical array reduction techniques that you can use. Okay. The two last things are unique values and sorting. So one thing that you might want to be able to do in an array, just in general, is to see how many unique values you are. So let's say you've got you've received a data set that's kind of got jumbled date values in it. And you want to be able to see, okay, how many unique dates do I have? Okay, and so this first input that I've got here, okay, is what I call a random integer array. So this is a randomly generated array. But what I'm doing is telling it that I want a random values between 100 random values, okay, which is this last value, between 1950 and 2016. Okay, so this is just to emulate kind of a jumbled up kind of list of years that you might find in a data set. Okay, so if I run that, you can see here I've got a list of years. Okay, so I've got 100 values in this array. Okay, but some of them might be duplicates. Okay, and so one thing that I want to ask is how many unique values are there? Okay, and so if I run this function called np.unique on the array that I'm interested in, okay, it'll spit out an array here that is just the unique values. Okay, and in this case it comes out sorted, and most of the times it will come out sorted like this. So in this case we have most of the values from 1950 to 2016, but not all of them. Okay, we're missing 2015, that didn't come up. Okay, and there might be an additional one or two in there that we don't have. Okay, so this unique gives us just a list of the unique values. Another thing that we can get out of this is to look at kind of the counts for each of those unique values. So how many unique values, so of those, that list of unique values, how many times is it repeated? Okay, and so this is a kind of an interesting one, and this is something you will see in future, is that some functions, okay, can actually return two variables. Okay, so in this case, so in this first case, we say np.unique, give it years. Okay, it spits us out a single variable that we're going to stuff into unique list. If we take np.unique and we return, or we add this extra option in here called return counts, then it's going to give us two outputs in this case. So we're going to get a list of the unique values like we did above, but then we're going to get a second array of the counts that go with that. Okay. So in this case, we're going to say, and this is just something you kind of have to dig through the documentation on and find. So we're going to say unique is the first variable that's going to come out of that. And then we'll say comma, and then counts will be the second variable that comes out of this. So when I run this, okay, you can see I get this variable unique, or uniq, okay? And then if I go up, I can see that I have another variable here called counts, okay? And so these match up one for one, okay? So if you look at these side by side, okay, 1950 shows up in that list 3 times. 1951 shows up 1 time. 1953 shows up 2 times. Okay, and we can go down and go down and go down. Okay, 2010 shows up 6 times. 2009 shows up 4 times. Okay, so this is just kind of an interesting, kind of another array reduction technique, is to look at unique values. Okay, so another thing that you might want to do is sort an array. Okay, and sorting is kind of tricky. You need to know which axis you want to sort on, whether you want to sort columns or sort rows. A lot of the sorting will actually sort each column or row independently from the whole data set. And so we're not going to go into this too much right now, but there are lots of ways to sort data. And so if you ever get into a situation where you need to sort a data set, you can come back here and look at these examples, or you can look in the documentation and see how to sort properly. So the last element for today is to look at a concept that will come up over and over and over again. Okay, and this is the idea of what we call masking, or sometimes this is called Boolean indexing. Okay, I like to call it masking. And so this is a way to basically select elements in an array that meet some condition, okay, or we say pass a Boolean test. So in this case, I'm going to create an array here, okay, of random values, just so we can see how this works. Okay, so this is a 10 by 10 array of random values. Okay, if you run this, yours will look different, since you're going to get different random values. Okay, but what I can ask Python to do is say, okay, which of these values in that array are less than or equal to 0? Okay, and that will give me what's called a mask array out. Okay, and so I usually call this a mask. as the variable name, but you can call it whatever you like. Okay, but if I run that, what you can see is that I get a new variable here called a Boolean array. Okay, and so basically, this is just saying, this is basically going through cell by cell and saying, in 0, 0, is that less than 0, less than or equal to 0? No, it is not. It's false. Okay. In my case, the second value there is minus 17, so that's true. Okay. False, 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 true, true, false, all the way down. Okay, through the entire array. Okay. And so, how is that useful? Okay, and I just less than 0 is just a really simple thing. Okay, you can actually do really complex masks as well. Okay, is that you can actually extract out those values. Okay, so if I want to get those less than 0 values out of, or pull them out and make a new array, okay, what I can do is say A for the array that I want to get those values out of, and then use our indexing kind of syntax here of brackets. But inside the brackets, rather than asking for a specific value, what I want to ask for is the mask. Okay, and so what this is going to do is go into the A array and say if it's false, okay, if the cell that overlays the cell that it's checking is false, it's going to leave it alone. Okay, if it's true, it's actually going to extract it. Okay, so if I run that, okay, you can see that I get an array out that is just negative values here. Okay, and these are in the order that they come out of the original array. Okay. Now, this has gone from a 2-dimensional array to a 1-dimensional array, so that's not necessarily that useful per se, but it gets you out the values that you're after. Okay, and so this usually comes in handy, you know, if you're looking at, again, an environmental data set where you know, I just need to do some operation on the negative numbers, or the negative numbers are more important than the positive numbers. Okay, this is one way to do it. Okay. If you want the opposite, okay, you can what we call invert a mask. Okay, and so in this case, if we add in this not function, okay, or not operator, okay, this will basically go through and say, okay, and if it's false, I'm going to pull it out. If it's true, I'm going to leave it in. Okay, so this does the opposite of that first one. Okay, you can do masking directly. Okay, so rather than up here where we say A and then say mask with this and then extract by that mask, okay, you can actually just put that Boolean test directly into the brackets there. Okay, so this is what we call a direct masking operation. Okay. The real power of this, okay, comes with doing math on those values, okay, and so that we have in our mask. Okay, so in this case, the way that this kind of reads out, okay, is that we're going to take A, okay, and then we're going to look at just the values in our mask. Okay, so this is, again, like looking at the indices of all of the true values in our mask. Okay, just like we did before in reassigning values. Okay, so this is A, and then we're just going to look at the values that are true in our mask. Okay, and then we're going to say equals, and then again we can say we just want to look at those true values in our mask, and then we can add, or we can do some operation on just those values. Okay, so in this case, if I run this, okay, I'm basically going to take all of the negative values in my A array, multiply them by 100, and stick them back into that original array. Okay, so this becomes a pretty powerful tool for in our data analysis kind of workflow, is to be able to mask and do operations on very specific parts of our arrays without having to extract them and then stick them back in, and you know, that can get kind of tricky. So doing these masks like this is kind of a skill that we'll work on through the semester, but you'll grow to love this, and it'll become kind of a key part of your data analysis toolbox. All right, so that's good for this one. And we'll see you guys next week.